All right, we are ready to go with topic 8 today. We're looking at lessons 1 and 2, proportional relationships with tables and graphs. We need to be able to recognize a proportional relationship in both a table and a graph. So some vocabulary we need to know is we need to first understand what a proportional relationship is. So it's a proportional relationship if, out of our two quantities, if y is always a constant multiple of x. So a relationship is proportional if it can be described with equivalent ratios. So for example, the red circles here would be my y values. So as I look at my red circles, I have 6 red circles to 3 blue squares. So y is a constant multiple of 6 because when I reduce this, it's a 2-to-1 ratio. I have twice as many red circles as I have blue squares. So that's what it means to be proportional, and I can always represent that in a proportional relationship by showing the equivalent ratios, two fractions that are equal to each other. So let's look at some other real-life examples. When you are in the cafeteria and every bag of chips you buy at lunch costs you 75 cents, so there's 75 cents per bag. So you have that proportional relationship between the cost and the number of bags you buy. For every concert ticket you bought, you spend another $25. That would be a proportional relationship, $25 per one ticket, 50 per two, and so on. So be on the lookout. You'll notice that there are lots of examples in real life that you may come across. Let's look at kind of a geometry example. We're looking at a series of squares, and we have the side length and perimeter labeled. So for our first square, the side length is 1 unit long, which gives us a perimeter of 4 total units to go all the way around. So if my side length is 1, my perimeter is 4. So if I'm going to write that ratio, that y to x ratio, then normally in tables we will list x and then y. So if I want to list my ratio, which is always going to be y to x, then I will put 4 over 1. So as I look at a square with a side length of 2, each side is 2. There are 4 sides, so that's a perimeter of 8. Side length 2 means perimeter 8. So as a ratio, I would say 8 to 2, which again reduces to 4 over 1. If I look at a square with a side length of 3, my perimeter is going to be 12 because 3 times 4 is 12. So as a ratio, I would say 12 to 3, which reduces to 4 over 1. So when my perimeter is 16 units, I can use a proportional relationship to figure out my side length. It's also easy because of the pattern in my table, but if I didn't have this other info, but I knew one of these other ratios, 1 to 4, 2 to 8, 3 to 12, I could easily use that to help me find the missing value here. And we did that a little bit last topic too. But I know that my perimeter is 4 times as much as my side length, so I need a side length of 4 for a perimeter of 16. So the ratio, that would be a 16 to 4 ratio, which again reduces to 4 over 1. When my side length is 5, my perimeter is 4 times as big, which is 20. And 20 to 5 reduces to a 4 to 1 ratio. And obviously a side length of 6 would have a perimeter of 24 because 24 over 6 also produces that 4 to 1 ratio. So when we ask, is the relationship between the perimeter and side length of a square proportional? It for sure is. Each of our ratios reduced to the same thing. So that means that our perimeter was in a proportional relationship with the side length because it's a constant multiple of the side length. The perimeter was 4 times as long as the side length. So it represented a constant multiple of the side length, which makes it proportional. So your turn to pause the video and try to fill out this table. This time we're looking at area. So remember that area is length times width. And in the case of a square, the length and the width are the same. So a lot of times we will say the formula for the area of a square is side squared because all the sides are the same. So pause the video and take a second to fill out this table and then check your work. As you filled out that table, hopefully you found that the relationship between the side length and the area of a square is not proportional because the area is not a constant multiple of the side length. In my first column of the table, the ratio is 1 to 1. In the second column of my table, the ratio is 2 to 1. And as I simplify these ratios in the following columns, I get 3 to 1, 4 to 1, 5 to 1, 6 to 1. So it's not a constant multiple, which means it's not proportional. So your key concept for today is that we can use a table to show a proportional relationship between two quantities. So sticking with that y to x ratio, we can pull that information from a table. So as I look at each row, each ordered pair, I can write it as a y-x ratio. And I'm looking for the same ratio to show up in each row. And as I look for that, I find that in every row of this table, it is a 2 to 1 ratio. So this shows a proportional relationship. Each y value is twice as big as its matching x value. So that's all I have to do to identify in a table is look at that y to x ratio and make sure it's consistent all the way through. So let's go ahead and pause the video and try that here on these 3 examples and then check your work. Looking at our first table, sorry about that, worked the wrong problem. Let's try that again. So if I'm looking at my y to x ratio, do it the correct way, which is comparing my y value to my x. Now this is easy to make a mistake because x comes before y in your table, so don't get pulled into that trap. This is a similar issue when we are looking at slopes of linear functions. So just keep in mind it's always y over x for our ratio. So as I compare all of these values, they all reduce to 1/2. If you get stuck down here, remember you can do our extremes over means, which would give you 2 over 4, which simplifies to 1/2. And we could do 5.5 to 11 by making this an improper fraction. So 11 halves over 11 over 1. And then I can do extremes over means, which again simplifies to 1/2. So we would say, yes, absolutely. This table shows a proportional relationship. All right, let's test out the next 2. Pause the video and then check your work. All right, in our second table, in each row, we find a 3 to 1 ratio. So we would say, yes, that's proportional. And in the third table, we have a different ratio in each row. We have a 1 to 2, a 3 to 7, a 1 to 3, and a 1 to 5. So this is most definitely not a proportional relationship. All right, one final checkpoint that you can make sure that you've got it. And I'm sure you found that we have alternating ratios. We have 1/5 in the first row, but then we have a 5 to 1 ratio, then we have a 1 to 5 ratio, then we have 5 to 1. So this one would most certainly be no. Reciprocal ratios are not equal. So in real life, we might be looking at proportional relationships and trying to use them to determine cost. So as we check out this table, we would want to decide, is this a proportional relationship? So sometimes, depending on the real life situation, you may just have larger values to calculate. So we're still going to do the y to x ratio, and we just need to make sure that as I compare y to x that it reduces to the same rate. So then I have 27 to 25, and then I have 55 to 550, and then I have 84 to 1050. So what I'm noticing in the beginning, as we reduce 18 over 150 to lowest terms, that would be 3 to 25. But I also noticed this fraction down here because this has a 1 to 10 ratio. So right off the bat, I know that this is not proportional because my cost is not a constant multiple of my number of copies. So definitely not proportional in this case. We're going to skip that because I think you've got it. Now what we're going to look at is graphs. So a graph can also be used to show a proportional relationship between two quantities. And when it does, there's two things to remember. The first one is that it always makes a straight line. The second thing is that it has to pass through the origin. And the straight line part makes sense. If it's proportional, it's constant. Your y value is a constant multiple of your x. It makes sense that each of our points should be distributed in a straight line. But it does also need to pass through the origin to be a proportional relationship as well. So as we're looking in a table, I can take these points, 4, 6, and graph them. So this becomes the first point on my graph, 4, 6. And then I have 6, 9, so I go over 6, up 9. Next, I'm going to go over 10 and up 15. And finally, I'm going to go over 12 and up 18. So starting at the origin, over 12, up 18. Now, this is a proportional relationship, but not a continuous function. So I will just leave this graphed as dots, but it does show a straight line pattern that goes through the origin. And it would make sense that in 0 seconds we would have 0 heartbeats. So here are some examples of what that looks like for you as you are examining graphs. As I look at my first graph here, I'm asking, is it a straight line? Yes, it's quite evident this is a straight line. My second test, does it pass through the origin? Yes, it passed both tests, so it's proportional. On part B, this looks great, straight line, but does not pass through the origin, so not a proportional relationship. And part C, it's got an interval that's straight and another interval that's straight, but it is not one continual straight line, although it does pass through the origin. However, it is not just a straight line, so it does not qualify as a proportional relationship. I think that part's pretty easy as long as you remember the tests. So let's try it on this one. You can pause the video and test yourself if you like. This is a great example of a straight line. It's a horizontal line, in fact, which makes it not proportional because it does not pass through the origin. This starts in the origin, so that part works, but this is a curved line, so this would also not represent a proportional relationship. So just examples of other graphs not to be fooled by. So now if we look at the equation y equals 6x, and we want to know if it shows a proportional relationship between x and y, we need to figure out how to graph this. So what can we do to help us graph this? Well, the other part that we have been looking at over and over and over today is a table. So we know in our table how to find our proportional relationship. So let's go ahead and use a table to help us graph this line. If this is the equation of my line, then let's pick a few x values. And since my graph starts at 0, 0, we'll make 0 my first point. And maybe we'll do 0, 1, 2, and 3. So if I put 0 into my equation for x, then that gives me y equals 6 times 0. And you can't read that at all, so let's try that again.